Welcome again to Let's Talk Advanced Chemistry, Chemistry 2 with Pastor Dan. We have 3 short problems here. So what I'm going to do is we're going to talk about Gibbs free energy, and we're going to practice on that. And then I'll throw some of these calorimetry problems in there with Hess's law and Gibbs free energy. So that way you know what to expect. So here we do. We got the first one, that complete enthalpy problem. Determine the total enthalpy needed to melt 100.85 grams of ice at negative 15.22 degrees Celsius to steam at 133.20 degrees Celsius. So it's that 5-step process. First, we got to increase the ice, then we have to melt it, then we have to increase the water, then we have to boil it, then we have to increase the steam. Number 2, calculate the capacity. So we're going to find the capacity Q of hot minus Q of cold, the absolute value divided by temperature change to find the capacity, the amount of energy that goes into the calorimeter. And then using that value for the third one, find the Q of the reaction. So for number 2, calculate the capacity. Calorimeter virtually has a temperature of 12.88 degrees Celsius for 50.00 grams of water. And when 50.00 grams of water at 65.23 degrees Celsius added to it, it's a final temperature of 38.21 degrees Celsius. And then for the last one, determine the enthalpy of the reaction. The calorimeter is found above, so we're using the capacity we find. If the reaction causes 300.00 grams of water decrease in temperature from a temperature of 18.76 degrees Celsius to 87.88 degrees Celsius, remember to include the capacity of the calorimeter in the problem. All right, so pause the video, work through those 3 problems, okay? All right, here we go. Here's the answers. So for the first one, we get 3,085 joules for the Q of ice. Then the Q of F, we get 32,886 joules. For the Q of water, we get 42,196 joules. For the Q of V, of that we get 228,930. Remember, we cut off to the 5 sig figs there. And then Q of steam is 6,696 joules. Add them all together, we get 314,793 joules. That's the answer for the first one. For the second one, Q of hot is... I apologize, I stumbled here looking at the problem. I fixed it afterwards. 165.3 joules. Oh, sorry. I can't quite read that number. Let's make that a little bit bigger for me. Oh, that's what it is. 5,653 joules and minus 5,299 joules. The difference is 354 joules. We take that and divide by the cold temperature of 25.33, and we get 14.0 joules per degree Celsius. And then we're going to use that to find the 300.00 grams times 4.184 times 69.12 degrees Celsius. We get 87,760 joules. And then we're going to add to that 14.0 times 69.12 degrees Celsius, and we get 968 joules. Add it all together, we get 88,728 joules. All right, that's it. Hopefully not too bad. Take care. God bless.